Okay, so I've done this video twice now and it didn't work. I'm going to try it one more time, but it's going to be two videos. So we're going to talk about electron pair geometry. Yikes. Come on. Oh, that's why. All right, electron pair geometry, and that's really dealing with the shape of molecules. That's what we're going to be talking about in this chapter, at least at the beginning. And we're going to talk first about something called the Vesper theory. Oops, that's supposed to be an R theory. So the VS is valence shell. That's just the outermost shell on an atom. EP is electron pair. And the R is repulsion. I wonder if you guys can hear my kids fighting in the background. I can. Anyway, so this valence shell electron pair repulsion theory just says that electrons are negative and they repel each other. So that's how we get molecular shapes, is by minimizing repulsion of anything with an electron. And anything with an electron can be a lone pair of electrons. It can also be an atom. So we're going to start by talking about a central atom with two, and I get really technical and I call them things. Now what are those things? Those things are atoms or lone electron pairs. That somehow says pairs. On the central atom. Okay. Sometimes they're called electron clouds. Sometimes it's called charge density. Lots of different terms. Every book I use uses a different term, so I made my own up. Just things. So what we're going to do is put two things, and we're not going to worry about what they are right now, on the central atom. And there's the central atom, and the furthest two things can get from each other on a central atom is 180 degrees apart. Because what happens is they push each other away until they are as far apart as they possibly could be. Now, if we were to say try to bring one of these atoms back a little bit closer this way, then the other atom will push it back, and that the 180 degrees is what we would call the equilibrium position. That's just where everything kind of settles out. We give this shape a name, and it is linear. Okay. In previous videos, I was jumping back and forth, or I did a split screen with a simulator for models, and it just didn't work. The software I was using couldn't capture it, so I'm going to run through all these shapes, and then I'm going to do a different video with the simulation. Okay, that one's really, really easy. Next one's pretty easy too. So if we do three things around the central atom, if you think about having a central atom, what's the furthest three things can get from each other? That angle is 120 degrees. Okay. And the name we give to this is trigonal planar. And the reason it's trigonal planar is because we have 1, 2, 3 things around the central atom, so that forms a triangle. And the planar comes from the fact that all four of these atoms, the central atom and the three terminal atoms, all lie on the same plane. They're lying flat on the plane of your screen right now. In the simulation, I will show you that, but I can't show you that now. Okay. Next up, after 3 comes 4. 4 things. Okay, here's where it starts to get a little bit complicated, because you might say, oh, 4 things, I know that bond angle, that's going to be 90 degrees, but it's not. Okay, and let me draw this and then I'll explain the drawing. So what we have here is these three atoms lying on the same plane. They're all lying on the plane of your screen. Okay, and then we have this wedge right here that I've colored green. It is sticking out at you. And then this dash is kind of going back. And the green wedge is kind of sticking out, down, and a little bit to the left. The pink dashes here, they are going back, down, and a little bit to the left as well. And again, when we get to this simulator, I can show you that. That'll be in the next video, of course. And this angle, I'm sure you all guessed this right off the bat, 109.5 degrees. Okay? And what name do we give that? Well, this is tetrahedral. If we were to kind of make a three-dimensional object out of this shape and kind of connect all the terminal atoms, it would have four sides, which is where we get the tetra part. Four, or tetra means four, and it would make a four-sided three-dimensional object, which is a tetrahedron. Okay, so that's tetrahedral. Next up, we have five things. And when we have five things, this is probably the most complicated one, because not all the positions are equivalent. They're all, well, not all, but there's two different positions here. And again, you're just going to have to forgive my slightly messy drawings. So let's get this drawn out and then we'll explain it. So again, we have these guys are all in one plane. They're all on the plane of your screen. And then if we look at the wedge, the yellow wedge is sticking out at you. And then the green dashes are sticking back. Okay. And again, the yellow is not sticking straight out at you. It's sticking off to the left there, and the green is also sticking off to the left. And now, if I highlight further, these three, actually I should say four, the ones I've just highlighted in blue, they are all in another plane, okay? They are in a plane that is actually perpendicular to the this pink line that's still visible there. And what that means is all of these guys are 90 degrees to each other. So that's 90 degrees, that's 90 degrees, that's 90 degrees. But when we look at those blue guys, the ones that are highlighted blue, they are 120 degrees from each other. Okay, I know this is getting a little bit complicated. Now, what does that mean? Well, what it means is we have two different positions on this molecule. It's not really a molecule yet, but this is the axial position. Okay, those two that I've used green on, those are the axial. And axial, if you think of it like an axle on a vehicle, it can spin on that axis. Or if you think of it like the planet, it spins on its axis as well. And then what's around the middle of the planet? We have the equator, and so these are equatorial positions. Okay, I know this is kind of difficult to follow when we don't look at the simulation, but when I get there, hopefully it will all make sense. All right, and last, six things. Oh my gosh, I forgot to tell you what that shape was, didn't I? Let's go back. That is trigonal bipyramidal. Trigonal, because we have those 3 equatorial positions, and that makes a triangle. And then there's 2 pyramids, one sticking up and one sticking down. Trigonal bipyramidal. Okay, 6 things. Let's draw that. Again, this one's a little complicated, although all of these positions are the same, so it's not quite as complicated as the previous one. So let's go over this guy real quick. Okay, these are all on the plane of your screen, the blue. Green coming out at you. Yellow going, that's not yellow. Yellow going back away from the screen. And then if we look, these 4 guys, I'm sorry, the 5 if we include the central atom, are on a plane that is perpendicular to these other positions. Okay, all of these are 90 degrees from each other. 90 degrees from each other. Again, it's much simpler when we look at the simulation. And this is called octahedral. Again, if we make a 3-dimensional shape out of it, it will have 8 sides and form an octahedron. That's why it's octahedral. Okay, that is 6 things. Again, they are all equivalent. That's enough for now.